Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Section 3 of Chapter 2, Standard Form. So far we have learned two other forms of a line, the slope-intercept form and the point-slope form. Each of those forms told us something specific about our line when we graphed it. Standard form is a little different. So let's take a look at what standard form looks like. So the standard form of an equation of a line could take one of two forms. You could have ax plus by equals c, where x and y are on the same side of the equals and some numbers on the opposite side. Or you could have ax plus by plus c equals 0, where all of your variables and numbers are on the same side of the equation and nothing is on the other side of the equation. Now when we work in standard form, we want to use intercepts to graph the line. So we're going to talk about what intercepts are in our next slide. So there are two types of intercepts when you graph a line, or two types of intercepts in general. Those intercepts are an x-intercept and a y-intercept. The x-intercept is the location where the graph crosses the x-axis. And we can find the x-intercept using the equation by following the three bulleted steps. We're going to plug 0 in for y, solve the equation for x, and then write our final point. What number did we get, comma 0, because y was 0. The other type of intercept we've already talked about, the y-intercept. The y-intercept is a location where the graph crosses the y-axis. For this intercept, if we solve it just by using the equation, we're going to plug 0 in for x, solve the equation for y, and then write our point 0, comma the number, because x was represented with 0. So we're going to do some problems where we find the intercepts. This slide is just to give you the steps. So let's do some different examples. So our first problem, we want to write 3x minus 2y equals 9 in slope-intercept form. So remember, slope-intercept form is the equation that looks like y equals mx plus b. So what we want to do is rearrange 3x minus 2y equals 9, so y is by itself and mx plus b is on the right. So what we want to do first is get rid of the 3x. So right now it's a positive 3x. So I'm going to do the opposite and subtract 3x from both sides of my equation. That's going to leave me with negative 2y on the left. And I want to write the other side so it has the form mx plus b. So the other form, I'm going to write the x piece first. Negative 3x plus 9 because it was a positive 9. My last step is y has to be by itself, so I have to get rid of the negative 2 by dividing everything by negative 2. So y would equal, and then you must simplify. So make sure you pay attention to if you can simplify your answer. Negative 3 over negative 2 would be positive 3 over 2 x. Positive 9 over negative 2 would be minus 9 over 2. So our equation in slope-intercept form, y equals 3/2 x minus 9 over 2. So this tells us, just to tie back in the first two sections, that the slope would be 3/2 because that's the number in front of x, and that the y-intercept is at the point 0, negative 9/2. So in the next slide, we're going to verify the y-intercept using the rules stated in the first slide. So using the same problem, we're now going to find the intercepts of 3x minus 2y equals 9. So when I find the intercepts, there's an x-intercept and there's a y-intercept. The x-intercept is always some number comma 0 because the x-intercept is when we plug 0 in for y. So what I'm going to do is take our equation, 3x minus 2y equals 9, and I'm going to plug in 0 where I see y to find the x-intercept. So once I plug in 0, I want to simplify it. Well, 2 times 0 is 0, so this piece goes away, and I'm left with 3x equals 9. And then I want to solve this for x by dividing both sides by 3. So I find that x is equal to 3. That means the x-intercept is the point 3, 0. That would be the first part of our answer. There is a point at 3, 0, which represents the x-intercept. Now, the y-intercept is a point you get by plugging in 0 for x and figuring out the remaining number. So what I'm going to do is this equation, I'm going to replace x with 0 and finish solving the equation for y. So 3 times 0 will cancel out because that's 0, and I'll have negative 2y equals 9 left. Divide by negative 2 on both sides, and y equals negative 9 over 2. So our y-intercept's at 0, negative 9 over 2. So we have two intercepts, the x-intercept and y-intercept, where the x-intercept's 3, 0, the y-intercept's 0, negative 9 halves. So using our intercepts, we can create a graph of our line, 3x minus 2y equals 9. So in the previous problem, we found there was an x-intercept at 3, 0. So on the x-axis, I'm going to plot a point at 3. And we also found that there is a y-intercept at 0, negative 9 halves. So at negative 9 halves, which would be approximately negative 4 and a half, I'm going to plot my y-intercept. And then I'm going to draw a line between those 2 points. And that line will be representing my line for 3x minus 2y equals 9. So plot your intercepts, connect them, and you have graphed your equation of the line. So our next example, we want to write 4x plus 5y minus 10 equals 0 in slope-intercept form. So what we want to do, we want to get the 4x and 5y all by itself on the left-hand side. So the first thing to do is get rid of minus 10 by doing the opposite and adding 10 to both sides of the equation. So we will have 4x plus 5y equals 10. Once we do that, we then want to get 5y by itself. So to get rid of the 4x, we're going to need to subtract that on both sides, because the opposite of a positive 4x is a negative 4x. So we'll have 5y equals negative 4x plus 10. The last step is to get y by itself, because slope-intercept form is y equals mx plus b. So we want to divide everything by 5 to get y by itself. So y will equal negative 4/5 x plus 10 divided by 5, which is 2. So we have the slope-intercept form of this equation is y equals negative 4/5 x plus 2. And just to review, that would then mean that the slope of the line is negative 4/5, and the y-intercept is at the point 0, 2. So we're going to verify that now by finding the intercepts with our steps. So we want to find the intercepts of 4x plus 5y minus 10 equals 0. So there are two types of intercepts, an x-intercept that occurs when y is 0, and a y-intercept that occurs when x is 0. So we're going to start by finding the x-intercept. So we're going to take the given equation and replace any y's with 0. When I do that, 5 times 0 would be 0, so that piece will cancel out. So I'm left with 4x minus 10 equals 0. If I finish solving this, I'd add 10 to both sides to have 4x equals 10, and then divide by 4. Now, 4 doesn't go into 10. However, 2 does, and 2 also goes into 4, so this would simplify to the fraction 5 over 2. So we would say the x-intercepts at 5 halves 0. Now, for the y-intercept, the same thing, but we're replacing x with 0. So 4 times 0 cancels out. We have 5y minus 10 equals 0. Add 10 to both sides. So 5y equals 10. And then divide by 5. So 5 goes into 10 twice. So the y-intercept would be at the point 0, 2, which matches what we found from the slope-intercept form. So using our two intercepts, we're now going to create our graph. So using our two intercepts we found in the previous problem, we can create the graph of our line. So we're going to plot a point at 5 halves 0. So 2 goes into 5 3 times with 1 left over. So that would be about 3.5. And then our y-intercepts at the point 0, 2. So I'm going to plot a point at both of those locations, and then I'm going to draw a line between them to represent my line of the equation provided. So standard form, we use the intercepts to graph the line. Now we're going to discuss two special cases of a graph when only one variable is present in your problem. So to graph the line 2y equals 6 using the intercepts, the first thing you want is for your variable to be solved and by itself. So what I need to do is get y by itself by dividing both sides by 2 to find that y would be equal to 3. So using the fact that y equals 3, I need to plot some points when y is equal to 3. So I'm going to start at the y-intercept when y is 3 and plot a point there. Now I need to go some direction from that point to figure out when y is still 3. So if I go up to 4, y has just changed values to 4. However, if I go to the right of this point and plot another point, my y value would still be 3. My x value changed, but y did not. Even if I would have went to the left of that point, my y value is still 3, but my x value has changed. So what we'll see that happens is that y equals a number is going to create a straight horizontal line at that number. And whenever you have a straight horizontal line, that means that your slope is 0. So you want to make a note of that. When we graph horizontal lines, your slope is 0. The other special case is when we graph the line 3x equals negative 6 using intercepts. So we want x to be by itself, so we need to divide both sides by 3 to find that x equals negative 2. When x equals negative 2, that means we need to plot points when x is always negative 2. So we're going to start on the x-axis at negative 2 and plot a point. And then I need to pick 2 more points where the x value is still negative 2. So I don't want to go left or right on my graph because my x value will change. Instead, I'm going to go right above and plot a point, and right below and plot a point. Because at those values, the x value is the same, the y value has changed. And then this means that I get a straight vertical line at that number. And whenever you graph a vertical line, a perfect vertical line, that means that you have an undefined slope. So this is not a slope of 0 like the previous problem where we got a horizontal line. This one's its own special kind of slope, which is called undefined. So make a note that when x equals a number, it is an undefined slope that creates a vertical line. This concludes our lesson on being able to use standard form. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.